Hi, this is your teacher, Charlotte Parker, and I'm just going to give you a tutorial here that's going to review a lot of the material that we have already covered in class, and we're going to go into a little bit more depth than what we have had time to actually cover during our classes. We're going to start with reviewing the first program, the one that I actually gave you the code for in homework number 3, I believe it was. If you take a look, what we're going to do, here's the code. First thing we want to talk about, what are the different parts of this program? We've talked about these hashtags are comments in the code. Anything that is in a line that has a hashtag preceding it, the program is going to ignore that information. This is a great way of adding comments to yourself as you are coding, and it's a good way to make sure that you include your name and the name of the program, as well as a brief description of what the code is going to do. You can add comments anywhere in your program. Again, this is a great way to be able to annotate what you are wanting your code to do. The next thing we're going to talk about is variables. A variable is something that can change value. It can vary. These are things that you get to decide the name of, and pretty much you can choose whatever name that you want to pick for it, as long as it's not already a reserved word in Python. Your reserved words are going to show up as different colors, such as int, input, if, print, your elif, your else. Those are reserved words in Python, so you cannot select those. You can It can include letters, it can include digits, and it can also include an underscore. It cannot begin with a digit. It can begin with either an underscore or a letter for the name that you pick for your variables. Now, when you first come up with a variable, what we like to do is what we call initializing it. So you will end up creating your variable name, and then you're going to assign it something that's on the other side of this assignment here. The equal sign basically is saying anything that's on the right-hand side is going to get put into what is on the left-hand side. Now notice that an equal sign, the assignment operator, there is just one equals. If you look later in the code, we have something that is an equals equals. This is a comparison. This is, in this case, if guess equals this value. This is the same kind of thing where later on we say if guess is less than or if guess is greater than. These are comparisons. This is an assignment. This one will actually change the what is inside of the variable. Okay, so in this case we assigned 42 into number. And in this next line, we are assigning whatever the user ends up giving them into guess. So we have here are called functions. A function, you can tell that it is a function because it includes parentheses. The number of parentheses that you have opening needs to equal the number of parentheses that are closing. So in here you actually have, let's take a look at input. Input is a function, and then it has an open parentheses and a closed parentheses. The information inside of it, the open quote, enter an integer, that is the parameter that is going into this function. And we also have here another function surrounding that one, which is converting those characters that the user types, that input, it's going to convert that into an actual number that your program is going to interpret that as a number, not as a group of characters. So whatever it is that the user types, we're going to convert that into a number, and we're going to store that in your variable called guess. There are, as far as functions go, there are a lot of built-in functions in Python. Right now the ones that you see, there's the input function, there's the integer function, and there's the print function. Those are the three that we're using. There are a lot of other ones available as well. We'll be learning more as our class progresses. We'll even later be learning how to create our own functions. But right now, these are the three that we are utilizing. We'll, like I say, keep introducing more and more as we go. The next part of the code I want you to take a look at are these conditionals here. We have an if, we have an else if, an elif, E-L-I-F, that means else if, and we have an else. So what we're doing here is if the guess that the user gives us is the same as what the true answer was that we assigned to Bing 42, the user has guessed correctly. They did a great job, wonderful, but they're not going to win anything. So that's why we have great job, you do not win any prizes. Notice that syntax here, at the end of this conditional, this line, there is a colon. So basically everything that follows that colon and is indented goes with this if. So if this is true, then do this and do this. If it is not true, then let's do another comparison. In this case, else, if guess is less than number, then print this statement. Else, print this statement. Now the difference between an else if and an else is your else if statement is saying you have another statement that must be true in order to fall into this. And else catches everything else that has not proven to be true above. So this is your default situation. So basically what we've done in this code is we said, is it equal? Okay. If it's not equal, is it less than? Okay, if it's not that, we're going to assume it must therefore be greater than. So print, no, it is lower than that. That is indented. Now this line down here at the very bottom is not indented. You notice it is not part of this if, it is not part of this else if, it is not part of this else. This will happen no matter what happens here. We will print the statement done. Okay, you've all run that code, you have seen what happens on it. Let's go ahead and now open up the code that you turned in to me today where you added a loop. And I'll go ahead and put these right here next to each other so you can compare the differences. All right. There are several ways that you could have done this code. This is one example of what we did. So I updated my statement of what the code does. We're going to let the user guess a number, and we will continue letting the having the user guess until they get the right answer. So that's the only change to the logic of what it is. All right, so to do that, we have to add what is called a loop. And the kind of loop we're adding is called a while loop. So if you notice, the if statement, the else if statement, and the else are pretty much the same as what we had last time. But now they have been inserted, tabbed under, they are now all part of this while loop. So basically, this code is going to continue looping and looping and looping. When is it going to loop? It is going to loop whenever the guess is wrong. That's what this variable is. So what I did is I initialized guess is wrong. When I created it, I set that to true. So while that's true, while their guess is wrong, ask the user for their input, enter an integer. You'll notice this line was right over here in your first code. Now it is inside of the while loop. So that's the first thing it's going to do when it hits the loop. We're going to get their guess. Now if they are right, do the same thing we did last time, but we are also going to change guess is wrong to false because they guessed right, they're no longer wrong, so that statement is now false. So if it's false, now we're going to come down, we're going to, because it hit this if statement, it's going to skip this else if statement, it's going to skip this else, it's going to come back up to the while loop. While guess is wrong, well, guess is wrong is now false, so that means the loop exits, it comes down, it prints done. Now, What if, in the more likely case, the user guessed something that was too low? The number is supposed to be 42 and they guessed 20. So what's going to happen? It enters the while loop. They enter an integer. They enter the number 20. That was their guess. The program checks, is guess 20? Does that equal the correct number, 42? No, it does not. Okay. Is guess 20, is that less than 42? Yes, it is. So print, no, it is higher than that. Skip the else statement. Okay. And come back up to the while loop. Guess is wrong is still the case because they guessed wrongly. So ask them again, enter an integer. They'll try a different number. And this is going to continue and continue and continue until they guess the right number. Guess is wrong changes to false. It comes up back to this while loop. Guess is wrong being false. Exit. It will print done. Notice that this print done is not indented. That means it is outside of the while loop. If any of y'all do music, y'all know what repeat signs are. Basically, your repeat is happening at the end of wherever all of these indents are and is coming back up to the while. And it's just a continual repeat until they end up basically being able to break out of that. Comes down here. All right. So now let's switch modes a little bit and talk about the assignment that I gave you today. If you'll take a look, what we're now going to be using are logical operators. Logical operators, we talked about that a few weeks ago when we talked about Boolean logic, and we talked about what to do with ands, what to do with ors, what to do with nots. You remember the truth tables that we ended up doing and that were on your homework several weeks ago. Well, let me show you a very simple program that will utilize an and just to minimize these. All right, now we have two variables. I just called it variable 1 and variable true. Okay, I set one of them to true, one of them to false. So here's our if statement. If variable 1 and variable 2 are true, print both are true. Otherwise, else, print at least one of these is false. So let's go ahead and try running this code. All right, and it just comes in and it says at least one of these is false. Why does it say that? Because the code that I actually put in here set this one to false. If this were instead a true, I'm going to save it and then we're going to run it. Notice now the output, both are true. Okay, now what we've done here, as a human I look at it and it to me is, you know, kind of clear that, okay, variable 1 true and variable 2 true. Now do this. But the second part of your assignment talks about test cases. So what we need to do is test every combination. So let's start with two falses. False and false. Okay? Alright. We need to save it. At least one of these is false. Okay? Now go through our truth table. Let's change one of them at a time. Let's change this one to being true. Okay, at least one of these is false. All right, and let's switch which one is false. Okay, save and run. At least one of these is false. Now, our final combination with both being true, save and run. Both are true. So now we finally hit that condition. So this is a very, very simple case. This is a simple case of being able to use two variables in a single if. Now what you're going to do in your assignment is we're going to take that same code that that you turned in to me today that had the loop, this one here, and we're going to add to it. Right now, it loops while the guess is wrong no matter what. No matter, as long as the user has the wrong answer, we're going to keep going, keep going, keep going. What I want you to do is I want you to now also ask the user, do you want to continue? Do you want to keep playing? Find out if they want to keep going. Based on their answer, quit the game if the user wants to quit playing, as well as if their guess is wrong. So, or if they, right now, it ends only if they get the right answer. Now I want you to be able to end the game if they have the right answer, or if they say, I'm done, that's it, game over. So you can use, I'm leaving this to you, you can use an and, or you can use an or. And to do those, you'll notice over here, it's just a reserved word, and. Another reserved word in Python is or. Another reserved word is not. All of those work just like those truth tables that we did in class. Here's those truth tables just as quick reference. Your truth table for an and, your truth table for an or, your truth table for a not. Okay. All right. Let me check my notes. Okay. So when you are doing your code, when you're making the modifications to this one here with the loop, again, you will not need to make very many changes to it for this assignment. Really, all you're going to have to do is you'll need to add another variable up here that is whether or not the user wishes to continue, and you'll need to check whether the user wants to continue at some point in the code and change that value based on what they give you, and then on this while loop compare both this existing variable as well as whether or not the user wishes to continue. And those really are the only changes that you need to do. You may be able to do this in about 3 new lines of code, may be all that's needed. But there are usually more than one right answer to do it, so you can still have a very functioning program if you do it with more lines than that. What I'm concerned with is think through it, make sure it makes sense to you, show me your code. I'd like to have a printout of it that is in your assignment. Notice here, turn in a printout. I've been letting y'all email it, and that works, but I really prefer for you to print it out. And then a screenshot of it's being run with all of your test cases. Now use those truth tables to be able to check all of the inputs into your while loop. You're going to have 2 variables here. With 2 variables, that means you're going to have at least 4 different inputs that you're going to have to give it to be able to test all conditions of those. So email me if you have questions. Feel free to contact me, and I will do what I can to answer it and get back to you. And I hope that this was helpful to you. Thank you very much.